Everyone, my name is Adil Azmat and today I will be going over AP Chemistry topic 8.8, Properties of Buffers. We'll learn what buffers are, how they work, and look at some real-world examples. So, what exactly are buffers? In chemistry, a buffer is a solution that resists changes in pH when an acid or base is added. They're composed of a weak acid and its conjugate base, or a weak base and its conjugate acid. So, how do buffers work? Buffers work primarily through neutralization reactions. When an acid is added to a buffer, the conjugate base neutralizes it. And conversely, when a base is added, the weak acid will neutralize it. This process helps maintain a stable pH. So, a prime example of the buffer system is the carbonic acid bicarbonate buffer system in our blood. This system is crucial for maintaining pH levels and keeping our bodies in homeostasis. So, components of carbonic acid and the bicarbonate buffer system are the carbonic acid, a weak acid, and the bicarbonate ion, its conjugate base. How does it work? So basically, when the blood becomes too acidic, the pH decreases. Excess H plus ions are present. That bicarbonate ions, HCO3 negative, react with these hydrogen ions to form carbonic acid. Eventually, this carbonic acid can be converted into carbon dioxide and exhaled by the lungs, effectively removing excess hydrogen ions and raising the pH. So let's see what happens when blood becomes too basic. When blood becomes too basic, the pH increases. There's an excess of hydroxide ions present in the blood. The carbonic acid will then react with the hydroxide ions to form bicarbonate ions and water, which can be put out as a waste product. This reaction will consume the hydroxide ions, lowering the pH back towards the normal range and keeping the body and the blood balanced and keeping the body in homeostasis. So, let's look at a practice problem. Okay, based on this problem, we are supposed to answer A and B. A solution contains 0.10 molar of hydrofluoric acid and 0.15 molar of sodium fluoride. Identify the weak acid and its conjugate base in the solution. Well, it's basically given in the question, but hydrofluoric acid will be our weak acid. Hydrofluoric acid is a common weak acid, and whenever you see it, it is a weak acid. And then obviously sodium fluoride will be our conjugate base. So B, explain how the solution resists changes in pH when a small amount of strong acid HCl is added. So basically, an important thing to remember about HCl or any other strong acid is that they dissociate. They are more prone to dissociate. So immediately they will dissociate into H plus and Cl minus ions. And sodium fluoride will also dissociate into Na plus N fluoride, F minus. Because hydrofluoric acid is a weak acid, it dissociates less. So the excess hydrogen ions from the dissociation of hydrochloric acid will form hydrofluoric acid by joining with the fluorine ions from the base to form a hydrofluoric acid, and this will cause a minimal change in the pH. F minus ions will react with H plus ions from HCl forming hydrofluoric acid, resulting in a minimal change in pH. Thank you.